In this video, we are looking at chemical bonds and how they link atoms. The first thing that we need to understand about chemical bonds is that it is the electrons of an atom that determine bonding. So electrons have, remember that I say live, they are found in the shells, the shells around or the cloud around the nucleus of the atom. So they're actually pretty distant from the nucleus, relatively speaking. Electrons are in different layers, more or less, of these clouds. So you have valence electrons, which are the outermost electrons, and then you may have other layers inside. The very first shell, electron shell, which is what we call these layers that the electrons exist in, the very first shell that's closest to the nucleus can contain a maximum of 2 electrons. The outer valence shell can contain a maximum of 8 electrons. And so what we find is that these outermost electrons are the ones that are involved in chemical reactions. And chemical reactions occur because of the creation of bonds or the breaking of bonds. So those valence electrons, the outermost electrons, are going to be the ones that are involved in chemical reactions. The first type of bond that we're going to look at is an ionic bond. We've talked about ions already. Remember that ions are atoms that have gained or lost electrons. So in the process of doing this, they will take on either a positive or a negative charge. The example that we're seeing here, we have sodium and chlorine. Sodium has a single valence electron. Now, a full valence shell with 8 electrons in it is considered stable, and atoms always are wanting to be stable. So because sodium only has a single valence electron in its neutral form, it's by itself, it's extremely unstable. So it wants to get rid of that outer electron, because if it does, then the next shell down has 8 electrons in it, and it's full, so it becomes stable. So in order to lose this electron, it has to find something to donate it to. Well, chlorine, in its outer shell, it has 7 valence electrons. It's not stable, it wants 8. So it is looking to gain an electron. So 2 very unstable atoms, sodium with its 1 that it wants to get rid of, chlorine with its 7, and it just needs 1 more to be stable. So what happens when they get close to each other is they are electrostatically attracted to each other. Sodium donates its electron to the chlorine, but in doing so, those electrons become bonded, and that is considered an ionic bond because it is a bond between ions. Once sodium loses its electron, it takes on a positive charge. Once chlorine gains an electron, it takes on a negative charge. We talked about that in the last video, why that occurs. And so once they're positive and negative, they're electrostatically attracted together, and that is what holds that bond together. Another type of bond is a covalent bond. These are very strong bonds that are formed when electrons are shared. So if we have 2 atoms of the same type, they're not going to be attracted to each other by the charge. So here we see fluorine. A fluorine atom has 7 valence electrons. Again, it's not happy because it wants to have 8. So we have 2 fluorines, but because they're the same type of atom and they don't have a charge, they're not going to be attracted to each other, but they still are unstable. So they want to get into some kind of bond in order to achieve that full valence shell of 8 electrons. So in the case of fluorine, if a fluorine atom is approximately close to another fluorine atom, they will actually share an electron and they become bonded together in that way. Both of them are now stable, which is why they stay bonded together. One special type, and very important type of covalent bond is a polar covalent bond. And these are especially important because they allow for hydrogen bonding, which is extremely important in living organisms. So a polar covalent bond occurs when you have atoms of different electronegativity. Electronegativity is how strongly an atom pulls electrons to itself. Oxygen, for example, has 6 valence electrons, but it also has a very high electronegativity. So because it wants 2 additional electrons to have that full valence shell of 8, it will bond with 2 hydrogen atoms because each of those has 1 valence electron. So it's looking to gain another valence electron. So by sharing an electron, the hydrogen, remember that first shell, so hydrogen just has that one electron in one shell. And I said that first shell can only contain 2 valence electrons. So because hydrogen only has 1 shell with 1 electron, it only needs 2 to be stable and have a full valence shell. So anyway, in order to achieve that, they will share electrons with an oxygen. Hydrogen is not very electronegative. Oxygen is very electronegative. That means oxygen is very greedy for electrons. It pulls the electrons very strongly towards itself. So in doing that, you get sort of an imbalance where the electrons are closer to the oxygen and a little farther away from the hydrogen. What this does is it creates what we call a partial charge or a partial positive or partial negative charge. And I'm moving my little mouse here. Here's a partial negative. Because the oxygen has pulled the electrons closer to itself, remember electrons have a negative charge, the oxygen will have a slightly or partial negative charge overall. At the other end, the hydrogens, which are not pulling the electrons quite as closely to themselves, even though they're sharing, they will take on a partially positive charge because those electrons are further away. So when you have a polar molecule, that just means it's kind of like something with poles. One side of it is a little bit negative, one side of it's a little bit positive. This means that when water molecules get close to each other, they will be attracted to each other. The negative end of the water molecule, which again, the oxygen end, which has that slightly partial negative charge, is going to be attracted to the partial positive charges containing the hydrogen. This holds all those water molecules together, and this creates the ability for water molecules to have cohesion and adhesion. It allows for these hydrogen bonds that are so important in things. Remember about, we talked about capillary action, surface. Well, we haven't, but we will talk about capillary action, surface tension. You will have experimented with those in your lab when you're putting the drops of water on the penny. The reason that water was able to kind of mound up on top of that penny was because of these hydrogen bonds holding those water molecules together.